Square root functions. Square root functions. Square root functions. Yeah. Okay. A square root function is a function that has a square root. And its main thing is a square root. So what we're going to do is make up some numbers. I'm going to pick these strategically. I'm going to pick numbers that can be square rooted. And I would love to dabble into negatives, but that would take us into the realm of complex numbers that we're not going to deal with. You may have known those as imaginary numbers on the high school level, but that's, I hate using imaginary numbers because they do exist. But anyway, we'll start at 0, we'll go 1, we'll go 4, and we'll also go 9, even though we won't be able to graph it. Okay, so the square root of 0 is, okay, something times itself gives me 0, that must be 0. Something times itself gives me 1, that must be 1. So far, so linear. Something times itself gives me 4, that must be 2. Something times itself gives me 9, that must be 3. So we're going to plot these coordinates, 0, 0, 1, 1. Don't fall into the linear trap. 4, 2. And then 9, 3 would be like way over here somewhere. And so this one's going to go like this. All right. The purpose of this lesson is to introduce you to different families of functions, the way the structure of the formula is and the way the graphs look. But I also want you to look ahead at some other things. And the thing I want you to look at here is a concept we're going to talk about later called inverses of functions. Notice that what you see here as a graph is exactly what you're looking at here, only it's turned sideways. So notice that. And we're not dealing with both sides of it, we're just dealing with the top of it. Okay, this is that. Not a coincidence, okay? Totally not a coincidence. I probably didn't represent that well. I covered up the wrong side, but whatever. We'll address that in the inverse lesson. But the point of what I'm saying is that squares, quadratic, and square roots are going to create graphs that are very similar in their shape, they're just turned a different direction. And there's more specifics to delve into with that. So let's take this idea, let's take that inverse idea and shelve it for a second or for a few lessons. And just wanted to give you a little taste of what's to come. And on this one, I would love to go through a table, and I plan to, but I also want you to realize that this one is a lot like this one. It's also a square root, clearly. But it's going to involve something you've already learned, and that's to translate a graph. And we did this with the quadratic. So this could be shifted up 3, like this one was. It was also flipped upside down, but this plus 3 shifted it up 3. So this plus 2 is going to shift it up 2. So 0, 1, 2, not 1, 2, 1, 4, 9. 1, 4, and then the 9 that we can't graph. And when I plugged in a 0, over here I got 0. Well, now I'm getting 0 plus 2, that must be 2. And when I plugged in a 1, I got a 1, so it's 1 plus 2, which is 3. When I plugged in a 4, I got a 2, but it's 2 plus 2, which of course is 4. And then this will be 3 plus 2, which will be 5, which I won't be able to graph. Okay, so 0, 2, 1, 3, 4, 4, and then 9, 5. Can't graph that one. It's everything you just graphed in the previous problem. It's just shifted up 2. See? There you go. You've seen this before. And again, I want you to see the similarities between one leg of this quadratic and then this graph as well. These are inverses of each other.